All right, here is a couple problems that I had questions about. So I'm going to zoom in here and let you guys take a look at these problems from the worksheet here. Okay, this is the first one, number 17. Number 17 says that you have an equilateral triangle that has a height of 26 centimeters. What is the length of each side of the triangle to the nearest centimeter? Well, the height means from the base directly up to the top, okay? Meaning it forms a 90-degree angle, okay? So we know that this right here is going to be 26, and I think it said centimeters. We also know from past experience that if I have a perpendicular line that goes up here, it splits this angle and it divides this up into two equal parts here. If it splits this angle, that means each one of these is 30. So essentially we have a 30, 60, 90 right triangle. So I'm going to take one of these right triangles. I'll draw it out here for you so you can see. Okay, I know this is going to be 26. Here's my 60-degree angle. Here's my 30-degree angle. And what I'm looking for is there's S. And remember, this is 2S. Now, the question asks me what's the length of each side. So I'm really looking for this side right here as my answer. But in order to get that, I have to find what S is. That is an S. It looks like a 5. I apologize for that. I don't like the fact that they use S. So in order to solve this, I know that 26 is equal to S times the square root of 3. So I can go ahead and I can solve that equation. So I'm going to write that down here. 26 equals S root 3. And to solve, we're now going to divide by root 3. And then I'm going to have S is equal to 26 over root 3. We're going to rationalize the denominator here, so I'm going to multiply the top and the bottom by root 3. And over here, that's going to give us 26 root 3 on the top over square root of 3 times the square root of 3 is the square root of 9, which is 3. So essentially, this is what S equals, okay? But remember, I don't want S because S is only this part right here. I want 2 S's, or I want double this. So if I want to double this, then what we have to do is we have to just take this and we have to double it or times it by 2. I'm just going to multiply, that's 2 over 1 times everything there. So S essentially comes out to be 52 root 3 over 3. But they want this to the nearest centimeter. So if you go 52 times root 3 and divide that by 3, you get almost exactly 30 centimeters as your answer there. Okay, here's number 22. And this was a tricky one because it said right triangle ABC, has an area of 32 root 3. The measures of A is 30, B is 90, which means this one over here has to be 60. So we're dealing with the 30, 60, 90 right triangle. And they want the lengths of BC, AB, and AC. So I got those over here. So we're going to find the lengths of all of these. The best way of going about this is to recognize that there's a formula for the area. The area is 1/2 the base times the height. Okay, so I'm going to do 32. I'll do this down here. 32 root 3 is equal to 1/2 the base times the height. Now the base, we'll call that this right here, and we'll say that this is the height. So in a 30, 60, 90 right triangle, this is S, okay, and this is S root 3. Okay, so we can now take these and we can plug these in for the base and the height. Okay, so the base we said was S times the height, which is S root 3 times 1/2, and that's going to be equal to 32 root 3. So we're just going to have to solve this for S. So the easiest way of doing this is get rid of this 1/2 first. So I'm going to multiply by 2 over 1. Oops, 2 over 1 and those cancel off, right? So multiply this by 2, and I get 64 root 3 is now equal to, I'm going to go s times root 3. So s times s is s squared times root 3. And now divide both sides by root 3. That's gone, which means s squared is equal to 64. Therefore, I know that the square root of that is going to be 8, so I know s is going to be equal to 8 here. I know this is going to be 8 root 3 here, and this over here is going to be 2 times s, which is 16. So there are my answers. AC is 16, AB is 8 root 3, and BC is 8. Those are my answers for number 22. Number 24 is the last one I had a question about, and that is about a real life problem that you can solve using a 45 to 45, 90 right triangle. Let's just say this. In my backyard, I want to string up some lights, okay? I've got a tree right here that I'm going to string some lights there, and a tree right here, and I want the distance here is, let's see, they said it was 18 feet. Okay, so what I want is I want these sides to be the exact same, and I want this to be a right triangle. Okay, so we're going to create this right triangle here. There's my right triangle, and I want to know where this point needs to be away from each one of those endpoints. That right there is a problem that you could solve. This is 45. This is 45 because it's an isosceles right triangle. And it says show your solution. So then you would just have to go ahead and solve this solution. So I know that 18 is going to be equal to s, which is the length of each one of these sides, times the square root of 2. And then you can go ahead and solve from there. That's my situation. Hopefully that helps. That is number 24, number 22, and number 17 right there. If you need any more help, let me know. Okay, here is the problem that you were looking at, that you texted me about. Okay, Sal's telling his entryway. The floor plan is drawn on the grid below. Each unit length represents 1 foot. So that means each one of these boxes, little boxes back here, is 1 by 1. The tile costs $2.25 per square foot. How much is he going to pay to tile this whole thing? So what we're going to do is the easiest way is to split this up into sections. And what I'm going to do is I'm going to split this up into this right here. Okay. This shape down here is a parallelogram, which means the base right here, which we're going to say the base is going to be 4. Sorry, it's tough writing with my finger. And the height is also going to be 1, 2, 3, 4, because you got to go straight up. Okay, so that's going to be 4 as well. Okay, so the area of the parallelogram is equal to base times height, which is going to be 16. Then this right here is a trapezoid. Okay, so a trapezoid is a little bit tougher to figure out. We're going to say the area of a trapezoid. Okay, and that's going to be base 1 plus base 2. So the base 1 is right here. 1, 2, 3, 4. The bases are the parallel sides. So that's 4 plus base 2, which is 1, 2, 3, 4, 5, 6, 7. Okay, base 1 plus base 2. Multiply it by the height. So the height goes from base to base. So it's 1, 2, 3, 4, 5. So we're going to multiply that by 5. Okay, and then divide by 2. Okay, so all we have to do now is 4 plus 7. We have to do order of operations. That's going to be 11 times 5. That's going to be 55 over 2, which looks like it's going to be 27.5. Okay, so that's going to be square feet there. And we've got this square feet here. So our job is to now add these two up. And if we add these two up, we're going to get the total square footage. Okay, and the total square footage looks like it's going to be 43 2.5 square feet. But that's not the answer, because the answer asks me for what is the cost, okay? And it's 225 per square foot. Well, there are this many square feet, so we have to multiply these two, and that's going to be your final answer. I'm going to let you do that math there. We're going to go on to the next page, and it is this problem number 7. So let's go ahead and graph this hexagon, and then I'll show you. We're going to use the area of a trapezoid again on this one, okay? So the hexagon, 6 sides. We're going to go negative 2, 4, 1, 2, 3, and 4. So I'm going to put dots right there. And then 0, 4, 3, 4, 0, 4. So we have that right there. We'll make it a little bit bigger. 2, 1, 2, 1, right there. 5, 1, 3, 4, 5, 1. And we've got 5, negative 2 right here. And negative 2, negative 2, negative 2, negative 2 right here. Well, that's kind of a weird shape, okay? So that's kind of a weird one. Let's go ahead and let's draw this out. And I apologize because I'm going to have to draw with my finger. So it's going to look something like this. Right there, right there, right there, diagonally there, and right there. That's a weird, kind of funky looking shape there. So what I'm going to do, we're going to split this up and find the area. Okay, so what I'm going to do is I'm going to split this up like this. And I'm going to find the area of this section right there. And this section is going to be, by the way, you could just count the squares if you wanted to, but it's 1, 2, 3 by 1, 2, 3, 4, 5, 6, 7. It's 3 by 7. And since it's a rectangle, we just multiply that, and that's going to give me an area of 21. Then I'm going to split it up right here. And this area right here is 2 by 3, so that's 6. And then this triangle is 2 by 3, so it's base times height, which is going to give you 6, but then you'd have to divide by 3, or divide by 2, and that gives you 3. The total area is all of these sections added up, so that looks like it's going to be a total of 30. And it says, we're just going to say square units, because it doesn't give me feet or anything like that, okay? Hopefully that makes sense. And one more. A composite figure is formed by combining a square, which we have here, and a triangle. And the total area of the triangle and the square is going to be 32.5 square feet. The area of the triangle right here, this part, is going to be 7.5 square feet. What is the length of each side of the square? Well, if the triangle is 7.5 and together they add up to be 32.5, then that means this area must be 25, because 25 plus 7.5 is going to give me 32.5. And to find the area of a square, it's this length times the width, right? And in a square, they're the same. So this is one number times itself to equal 25. And I know that that one number has to be 5. So the length of each side of this is 5. Hopefully that helps. Let me know if you have any more questions. See ya.